Episode 2, Understanding Variables. If we open any example from the large array that processing includes, all of them include variables of some description, denoted by their orange/yellow color. Boolean, int, float, int. You'll see a pattern emerging. No matter what you open, only the same sort of 4 words keep reappearing. Float, color, int. So what is a variable? It doesn't matter what it's doing or what it's used for. At its most basic level, a variable is a slot in the computer's memory allocated for that program. In this case, the variable is called d with a value of 20, or in this case it's a variable called middle with a value of the width of the screen divided by 2. And this is a perfect example of how variables can work. They can be declared to equal something specifically, or inline in text, they can be changed to something else. Boolean here that is declared as false before the program runs is then declared as true during the running of the program. Let's start a blank file. I'm going to quickly set up my program. There are 4 categories of variable separated into 2 different types. We have global and we have local. Global variables are generated in the initialization state, accessible everywhere in the program. It doesn't matter whether it's setup, draw, or a new function that you're writing. Anything between 1 and the end of your program will be able to access a variable here. Local is contained to a function. So no matter what the variable is or what it's doing, it will only exist within the curly brace of the function in which it's defined. One of the main use of a function is to carry out complex calculations or validate a value, but you don't need to have a variable that exists throughout your program for that. So we use functions to section off large complex pieces of code that require a large number of variables. We'll look at this in more detail in future episodes, but for now, a lot of our variables will be globally defined, so accessible anywhere. So those are the 2 categories, but there are 4 main types of variable that we will use constantly, and some others that do exist that we will use as and when needed. No matter what the type of variable, they're all defined the same way. First, we say its type, then we give it its name, and then we have the option to declare the variable. And note the semicolon to end it. When you declare a variable, you're saying that it's equal to something before it's actually needed to be used. This is important, as an undeclared variable, if I can spell, is always going to be equal to the string and value of null. This is important, as if you try and do maths or a calculation with a null variable, you will receive an error. Whereas if you define a variable that is, say, a number to 0 versus null, it will be usable within the program. So, the 4 main types of variable. Int, which is short for integer, or a whole number. This just means any number that is not a fraction. So whether it's 0 or 10 million, int will be able to contain it. It's probably one of the most common values that we will use to avoid complex floating point calculations at the moment. The second is a float. Well, similar Float is short for floating point number. It basically means any number that is a decimal or a fraction. So whether it's 100.2 or 0.5, a floating point is required for us to have decimal numbers. Hence, the float refers to the moving of the decimal point. There are different uses for each, but given the ability of modern programming environments, ints and floats are often interchangeable if a whole number is present. A float can be equal to 1 as well as an int, so using them in error may not break your program. However, processing is well developed and should be able to pick up where these mistakes occur. The third variable is a string, and please note the capital S when defining a string variable. String variables are used to hold text, a list of characters, and they are specifically denoted by the speech marks on either side of their input. Whereas a string can be equal to anything, whether a text, a number, or a character. If it's not within speech marks, it will not be declared as a valid string. So if you receive errors, it's normally due to the absence of double speech marks. The fourth and final variable that we will use commonly is called a boolean. And as we saw in the previous example, these are simple true and false values. We use them to error check and validate our work as we go. Some parts of program will check whether a value is in or outside the visible screen, or whether a large calculation is correct. They can only ever be true, false, or null if undeclared. We'll look at these in more detail in a further episode. Now that a variable has been defined, to recall it and use it within any part of the program, all we need to do is simply reference its name. For example, if I wanted to give variable 1 a value, since we left it undeclared, in setup all I'd need to write is variable 1 is equal to 1. End my command. This is a valid line of code, and it's a valid use of a variable. So on initialization, we allocate an integer variable into memory, but don't give it a value, so it's equal to null until this point on line 16, where we change its value to 1. So now any point in the program after this, e.g. in the draw loop, until we change it, variable 1 will always equal 1. We're going to use today's referencing task to showcase this. So open our reference from the previous version. And in the initialization section, we're going to add some variables, whatever you choose. Do int, integer 1, int, integer 2, and then let's do a string 1, Not only can we set a variable, as we did in the previous example, we can also access it. So, for example, in the setup, I'm going to print out the value of each of these variables. I'm going to do print integer 1, I'm also going to add a special print command to the last in the line. Adding ln to a print command moves the carriage return ln notes print command carriage return. And what that means is that after it's print this command, it will start a new line on the console. We do this to remove clutter when printing multiple variable tests over and over and over again. For example, the draw loop hello. We could do print ln, which means hello would be printed in a list rather than consecutively. So, on running the program, we can see we get 0, 10, and hello. Integer 1 is set to 0 because it's null, as we understood from the initial declaration. Using this would have no purpose. So, after initially printing the results, I'm going to change the value of integer 1. And this will help showcase the way that the program works. I'm going to change the value of integer 1 to 100, and then I'm going to reprint its value to the console. What do you think the output will read like? Disabling the other two outputs for now for clarity, you will see that the output becomes 0, then 100. This showcases the ability to both set a variable in line with the program and its top to bottom sequential reading order. Let's move this initial integer setup into the draw loop. What I'm going to do is I'm going to add a new print command, print ln for clarity, and I'm going to do integer 1. Pressing play will simply print the value of integer 1 into the console over and over again. But what happens if we continually update the value of integer 1? For example, integer 1 is equal to integer 1 plus integer 2. So what does this line of code actually say? Add the value of int 1 to the value of int 1 plus int 2, or 100 is equal to 100 plus 10 on the first loop. After the second loop, it will be 110 is equal to 110 plus 10. 120 is equal to 120 plus 10. And this is the formation and an insight into the power of being able to program loops. We will get onto loops in the next exercise and how to control them and operate the flow of a program better. For now, we'll simply just test whether that theory works out. In the console, we should see a continually rising stream of numbers, and this is due to the fact that integer is continually being redefined by its previous value. This is where draw comes into its own and its ability to loop. The ifs, for, and while loops will cover the ability to terminate these loops and have special actions triggered when numbers reach certain value. For now, I'm going to save this and close my reference and my initial sketch. Open up our main program. Let's add some variables to it. Keeping it simple, we are going to draw a rectangle using variables. Now, a rectangle in its simplest form is drawn using the rectangle command. Now, if you're unsure what this means, we can right-click it and use the find and reference skill. As we previously discussed, find and reference will take us to the specific processing page that tells us both the syntax and the description of what rectangle does. In this case, it tells us that in its basic form, rectangle is expecting 4 values that equal the x, the y, the width and the height of a box within our space. Before we can do that, we need to define the size of our processing sketch, and this is done in setup. Size, type in any numbers you want smaller than your screen resolution here, changes the way that the box is drawn. So you can see that's a 500 by 500 pixel. This is a 5000 by 500 pixel box. This extends well beyond the reach of my monitor. For now, 500 by 500 is a good working space. We need to work out how to draw a rectangle. So, we know that it was expecting an x coordinate, a y coordinate, a width, and a height. So doing so should draw a rectangle at the coordinates 10, 10 with a width of 50 and a height of 75, within our 500 by 500 space. And there it is. These colours and border are set by default, and we'll look at how to change them later on, but for now we know it works. But hard coding these numbers every time is easy for one rectangle, but what happens if we had 10 rectangles all at different places, offset from each other? We can do it using variables in the same way that we printed the variable out. So at the top, I'm going to initialize 4 different variables. I'm going to do integer xpos, int ypos, int box width, and int box height. I'm going to set these up within the setup. So we're going to have xpos is equal to 10, ypos is equal to 10, box w is equal to 10, and box h is equal to 10. Let's make this a bit bigger. So 75 and 50 were the values we used before. So now I can use these variables to draw a rectangle using nothing but variables. Admittedly, this is very convoluted to draw a single box, but let me show you an example of where it's usable. So now we have one rectangle drawn with variables, but what happens if I want to offset another box on top of that one using a simple copy and paste and an adjustment of variables? I now have 2 rectangles based on a single set of values. This is where variables and inline adjustment can be powerful. We will use this and the power of variables later to begin moving a box through loops. For now, I'm going to save my main task and close it.